Welcome to RG classes, and today we will do critical angle and the total internal reflection, that is the part of refraction. Word you are hearing that the reflection, but it is not about the reflection, but it is the part of refraction where reflection take place. So first of all we are going to understand what is critical angle. So one of the important thing that you will have to keep in mind, critical angle, because whenever the value of angle of incidence reaches to the critical angle, behavior of the light changes. So that change in behavior, that needs to be studied only understanding the critical angle. So first let's understand critical angle. What is critical angle? And before doing that, I'm doing some simple things. In refraction of light, we have studied the behavior of light when it enters from the rarer medium to denser and from the denser to rarer. So this time we are going to understand the behavior of light when it enters from the denser medium to the rarer medium. Because for the critical angle, in order to get the critical angle, proper description of the critical angle, we should have the proper knowledge what will happen, what can happen when light enter from the denser medium to the rarer medium on increasing the angle of incidence. Okay, so we have a format, this one. Now this one is the rarer medium and this one is the denser medium. Suppose we have an incident right at a particular angle. This one is the angle of incidence. For this angle of incidence, obviously we will have some angle of refraction, obviously. Suppose in next condition we increase the angle of incidence little bit. Suppose this is 30 degree, then we increase it by 5 degree, 35 degree. That means little by little we are increasing the angle of incidence, and we will study the behavior of angle of refraction or the refracted ray in such a condition. What happened? Suppose this was the angle of incidence, then the angle of refraction was this one. Understood? And this time again we increase the angle of incidence little bit. So in under that situation we notice that the ray of light will bend towards the क्या जाएगा, surface separating the two medium. It will refract little more. So this time the refracted ray will be something like this one. That means angle of refraction has been increased. So with increase of angle of incidence, angle of refraction has also been increased. Again in third situation, if we continue in this manner, so suppose now this time we have increased the angle of incidence little more. So under that situation you will find that the angle of refraction, refracted ray will be on the surface separating the two medium, that is on this surface. Refracted ray, this one will be the refracted ray. So refracted ray will come to this surface, and when refracted ray come to this surface, so under that situation angle of incidence will be, angle of refraction will be the 90 degree. That means there is a particular angle of incidence, for that angle of refraction will be 90 degree. So and that angle is said to be the critical angle. That is said to be the critical angle. Critical angle. That means we understand from this one only. That means as gradually we increase the angle of incidence, angle of refraction will also increase, and finally it will reaches a value that is equals to 90 degree. And under that situation, when the angle of refraction reaches 90 degree for a particular value of angle of incidence, and one thing that is to be keep in mind, that is light should travel from the denser medium. So angle of incidence in the denser medium, particular value of angle of incidence in the denser medium, for which the value of angle of refraction in the rarer medium is 90 degree. So that particular angle of incidence is said to be the critical angle. It is represented as IC, critical angle. So now if we need to give the definition of the critical angle, so what will be the critical angle? Value of angle of incidence in the denser medium. Keep in mind always you will have to travel the light, you will have to incident the light from the denser medium to the rarer medium, then only there will be the concept of critical angle. If you allow the light to fall from the rarer medium to denser medium, there is no concept for the critical angle. So the critical angle, our definition will be the value of angle of incidence in the denser medium for which the value of angle of refraction in the rarer medium will be 90 degree is said to be the critical angle. Again, I am writing this definition, I am writing it for you. So critical angle, value of angle of incidence in the denser medium, value of angle of incidence in the denser medium for which the value of angle of refraction is equals to 90 degree in the rarer medium is called critical angle. That means critical angle, from the concept of the critical angle we understood one thing, that the value of critical angle for any substance will always be constant, will have a particular value. It can be 40.5 degree, 42.5 degree, it can be 45, it can be 47. So whatever, it will remain constant for a particular substance. So critical angle understood. So in order to be the critical angle, in order to get the critical angle, what are the conditions required? The first condition, that the light must travel from the denser medium to rarer medium, factors and the conditions. So the first condition that affect that light must travel from the denser medium to rarer medium, and the value of refraction, angle of refraction must be equal to 90 degree. So then there will be the critical angle. Okay, after critical angle we have the another term, that is the total internal reflection. Okay, total internal reflection, I am going to that concept and continue with this diagram. So in first diagram we understood that for a particular value of, so we have an angle of incidence, and for that refract in the denser medium and it bend away from normal. Again, on increasing the value of angle of incidence, value of angle of refraction also increases. And again in third case we notice that, so for a particular value of angle of incidence, that is the critical angle we called it. So for the particular value of angle of incidence in the denser medium, the value of angle of refraction in the rarer medium was 90 degree. But suppose what will happen if we further increase the value of angle of incidence? That means this time we are keeping the value of angle of incidence more than the critical angle. So if we keep that one, so according to, in that case, this one is the first diagram, second diagram, third diagram, and this one is the fourth diagram we have. So in that case, that means this time angle of incidence is more than the critical angle. So I increase this one. This one is the angle of incidence and it one is greater than the critical angle. So under that situation, again what was happening? So as means we were increasing the angle of incidence, the refracted ray were bending towards right, towards the surface separating the medium, and again on further increasing it will not remain here, it will it will move again this way. That means it will enter into the denser medium. This one, it has means on the critical angle, at the value of the critical angle, it has reached up to the surface separating the two medium, and again on further increasing the value of angle of incidence, it will move to the denser medium only. So in that case the ray of light will move to the denser medium, this one. That means now the things to be noticed, light has traveled from the denser medium and again it has entered into the denser medium. So whenever light traveling from a medium entered into the same medium, what is that is called? That is called reflection. Although it is the transparent medium, but due to a specific value of the angle of incidence, light did not refract. light is reflecting this time, that means light entered into the same medium, that's why, and this one is called total internal reflection. Why it is called total internal reflection? First of all, light has traveled from the denser medium and it entered into the denser medium, that's why it is internal. It is not entering into the other medium, so terms is called internal. And again, it has entered into the same medium, traveling from the same medium, it has bounced back into the same medium, that's why term is called reflection. And why total? Whole amount of the light. What generally happen whenever the light strike on a surface, some amount of the light is being absorbed by that surface, some energy is being absorbed by that surface and rest of being refracted or reflected. But in this situation, whole of the light that incident on the surface will get reflected back. That means not even a trace of the energy will be absorbed. That's why the word has been used total. Energy is not absorbed here. The total amount of the light energy that incident on the surface that get reflected, so that's why the term has been used the total. And obviously reflection is because it entering from the medium to the same medium, that's why it is called total internal reflection. Total because means whole amount of the light energy that incident on the surface get reflected by it, not even little trace of the energy is being absorbed, that's why the total internal reflection. So I hope you have understood what is total internal reflection. So in order to give the definition, if we need to give the definition and then we will come to the condition required. So if in order to give the definition, what will be the definition of the critical angle? Total internal reflection. Whenever light travel at an angle greater than the critical angle from the denser medium, whole of the light get reflected back in the denser medium. So that is said to be the total internal reflection. So total internal reflection. And now what are the conditions required for the total internal reflection? Now we are going to the conditions required for the total internal reflection. Now first condition, in order to be total internal reflection, yes, light must travel from the denser medium. Yes, in this situation also light will have to travel from the denser medium. So first of all, light must travel from denser medium, okay. And the second condition, that is the most important condition, the value of angle of incidence must be greater than the critical angle. So in this situation, value of angle of incidence must be greater than the critical angle, so that was the critical angle and the total internal reflection. Now we are going to find the relation between the critical angle and the refractive index. Now a relation between the critical angle and the refractive index. Suppose a ray of light entering from the air to glass, or first of all we are going to find the relation for the refractive index for the medium with air with respect to water. Suppose if we are finding the refractive index of air with respect to glass. So if we find the refractive index of air with respect to glass, what will happen? So refractive index, in term of angle, we have the refractive index equals to sin I by sin R. That is the concept of refractive index. Obviously for refractive index we have the two definition, in term of angle and in term of the velocity of the light. So here angle is required. So refractive index is defined as the ratio of sin I by sin R. Okay, now this time we are finding the ratio of refractive index of air with respect to glass. What will happen? So in that situation, angle of incidence, that is the critical angle, sin C by, that means relation between the critical angle and the refractive index. So critical angle, that means angle of incidence will be equals to the critical angle. So this time sin C, and angle of refraction for the critical angle, that will be equals to 90 degree. So here it will be the sin 90 degree. So this one is the refractive index of air with respect to glass. But if we find the refractive index of glass with respect to air, so it will be 1 by mu Ag. That means if we reverse this one, we will get the refractive index of glass with respect to air. That means we have understood, we have studied, it means while doing the refractive index, so whenever we are doing the refractive index of a particular with respect to another, so whatever the value we have, if we reverse the value, so we will get the refractive index of the other medium with respect to this one. So in such a situation, so we have value this one. If we put the value, this value of this one is air with respect to glass is this one. So mu Ga, glass with respect to air, so 1 by sin C by sin 90 degree. And it will be equals to, now here it will be equals to, so glass with respect to air equals to sin 90 degree by sin C. So sin 90, the value of sin 90, that is equals to 1. So where here we have the value mu Ga equals to 1 by sin C. So here refractive index of a particular medium will be inversely proportional to the critical angle. So this one is completed, critical angle, we did critical angle, and this one. So after that we will do the factors affecting the critical angle. Now what are the factors? So on what factor? The critical angle depend upon first of all wavelength. So with increase in the wavelength, the critical angle of a substance increases. So I'm not going kya jayega means in detail, more detail about the, so increase in the wavelength. So if the angle means wavelength of a substance increases, the value of the critical angle will also increase. Again one, dependence on the temperature. So also the critical angle increases with the increase in temperature. So we have the two value, the wavelength and the temperature. So the critical angle increase is directly proportional to the wavelength, and the critical angle is directly proportional to the temperature. We have the two factor, critical angle is directly proportional to the temperature. So with increase in temperature, critical angle will increase, and also with increase in the wavelength, the critical angle will increase. That is the two factor. Now okay, we have wavelength, and how is the wavelength related to the refractive index? So we have studied that the wavelength is inversely proportional. Sometimes you will not have been given the wavelength, and you will have the questions related to the refractive index. So now the third question, how is the critical angle related to the refractive index? And third question we can write, third factor, that is the refractive index. So refractive index, now we have done this one. So refractive index, so critical angle is inversely proportional to the refractive index of the medium. So these are the three factors that is about the critical angle. So critical angle, we understood critical angle, that means it was a fixed value for which the angle of refraction in the dense rarer medium will be 90 degree. Now again the next was the total internal reflection. So the value of angle of incidence, if greater than the 90, means critical angle in the denser medium, for that the ray of light will not suffer refraction, it will suffer reflection, and that will be called total internal reflection. And the third thing, the factors we understood, and the relation that is between the refractive index and the critical angle. So this one, and the next video we will understood the means we will study some ray diagram means about the total internal reflecting prism. So total internal reflecting prism through the deviation of 90 degree, deviation of 180 degree, and some more diagram. So only diagram is important from that section, the refraction through the prism. So diagram is important from that section, and some applications, and nothing else. So in next video, so keep in mind all these things. In next video we will do the refraction through a total internal reflecting prism, deviation of 90 degree, deviation of 180 degree, and other isosceles prism means refraction through the isosceles prism. So all these we will do in next video.